Asfi, are you ready?
Yes, ma'am. Yes, ma'am.
Sharp 10 o'clock, just, okay, click of 10, start the program.
Yes, ma'am. Okay.
Yes, good morning, ma'am.
Good morning. Rameshi, can you please on your video, if you don't mind?
Shall we start, ma'am?
Yeah, exactly 10. You can start the program, Asfi. Good morning,
very good.
Ramesh Garu. Good morning.
A very good morning to all the participants. A warm welcome to all of you to the fourth session of 10-day faculty development program on advanced research methodology sponsored by ICSSR. At the outset, I take the privilege of welcoming today's resource person, Dr. K. Ramesh Garu, to this technical session. Sir will handle the session as a resource person for the day, and Sir will deliver his lecture on creating graphs, histogram, box and whisker plots, error bar charts, variable and scatter diagram. Before I hand over the session to Dr. Ramesh Sir, I would like to briefly introduce Sir to the audience. Dr. K. Ramesh Garu is currently working as assistant professor in the area of business analytics, School of Business, Geetham University, Hyderabad. He has qualified UGC NET with JRF. Sir has received a PhD from Osmania University. Sir has published various papers in Scoopus Indexed and ABC listed journals. Sir has presented several research papers at various national and international conferences. Sir's area of interest includes business analytics, quantitative techniques in management, data visualization, data analysis, and machine language. We welcome you, sir. I hand over the session to you, sir.
Thank you, ma'am. Morning to all participants. We'll share the one link. You can download the data sets. Please check your chat box. I sent one link for data sets. Please download the data sets from that link. Yeah, is it accessible? Check once that link.
Yes, sir, it is accessible.
Please download the data sets, everyone. Yes, download everyone. Shall I start? Please download the data sets. In last 3 sessions, yeah. Is it visible my screen?
Yeah, we can see your screen, Ramesh.
Yes. So in the last sessions, we discussed different statistical methods, descriptive stats. So in today we discuss about statistical charts. Before discussing statistical charts, I'll give you overview of the statistical methods. So which statistical method suitable for which type of data? Okay. So is statistical charts part of statistical methods? I'll first explain different statistical methods. So we can see this data set. In TIPS data set, everyone open the data set. We have different variables here: total bill, tip, size, sex, smoker, day, and time. So this is the different types of variables. So every statistical method depends on data and objective. Okay, so your all statistical one is your objective. Okay, what type of data you have, either qualitative or quantitative. So what is our objective? To find the relationship. You want to compare the between groups. You want to find the relation to find the association. You want to find the effectiveness. Okay, based on our objective, based on the data type, we can select the statistical methods. If I select the two variables like smoker and total bill. If I select smoker and total bill, so which statistical method is suitable for these variables? So anyone text in chat box? If I select, yes. If select the total bill and smoker, so which statistical method is suitable here? If I select the total bill and smoker, so which statistical method suitable for this variable? Yes, some texted relationship inference. Okay. So which is suitable here? If you have only two variables, one is total bill, one is smoker. Yes, which the statistical method suitable, either t-test or correlation or regression. Some people correlation, some people texted t-test, some people Anova. Yes, please text your chat box. Yeah, if you have smoker and total bill, so many texted correlation. Okay. The next question is, if you want to find the, if you select the two variables, one is sex, second one is smoker. So which test is suitable? If select the smoker and sex, please text your answer in chat box. If select the smoker and sex, yeah, chi-square, yeah. Yeah, so many texted chi-square. Okay. If you select the total bill and tip, which test? If total bill and tip. If select the total bill and tip, two variables. One is total bill, second is tip. Yeah, correlation. Yes. Yeah. Yes. Okay. So, so many text right answers. So before going to statistical charts, I will explain what is the stats, what are the different methods in statistics. So before selecting a statistical method, you have to decide which type of data you have, either qualitative or quantitative. Okay, we can call variable also. Variable is nothing but data item. Okay, it's a characteristics or attribute. Okay, it's vary from one entity to another entity, because if one has total bill $15, okay, it's vary from one person to another person. So that's why it's called variable. So here only two types of variable. One is qualitative, one is quantitative. Based on our data type, based on our objectives, we can select the statistical methods. So here quantitative, again two types. One is descriptive, one is continuous. Again, qualitative, two types, nominal, ordinal. So what is quantitative? We can express the numbers. So like age or income, salary, these all are numerical variables or quantitative data. Okay. So we can write a data or variable divided into two parts. One is quantitative, one is qualitative. Again, quantitative we can classify it into discrete and continuous. So what is discrete? We can countable. So number of participants in this workshop, number of students in classroom. Okay, that is countable. That is discrete data. Next, continuous, uncountable, but we can measure it, like a person height, weight. Okay, here we can countable, here uncountable, but we can measure it. Okay, this is number of students in class, number of participants in workshop. Your person weight or height are the continuous variables. Again, qualitative data. So what is qualitative data? So we can't express it in numbers. Okay, that is qualitative data. Either here qualitative data, two types. One is nominal, second is ordinal. So nominal starting with NO. Yes, we can't measure in numbers. So nominal starting with NO, there is no order. Okay, there is no order. That is nominal data. If there is order, that is ordinal data. For example, gender. Okay, we can select first questionnaire male or female. Okay, what is your region? South, north, east, west. Okay, we don't need to bother about the order. That is nominal data, like gender, region. In order, how to write the order wise. For example, socioeconomic status, low income level, medium, high income levels. Okay, that is the ordinal data. So before selecting statistical method, first what type of data you have, either qualitative or quantitative. Yeah. So what is stats? Yeah, we already discussed discrete, continuous, nominal, and ordinal. Okay, here discrete is countable, a continuous, measured, nominal, there is no order, we can categorize it, ordinal with order. For discrete example, number of students in a class, continuous, a person height or weight, nominal like gender, in ordinal, low income, middle income, high income. So coming to our data set, so here, is it visible my screen, Excel screen? Yes. Okay, here total bill is which type of data? Total bill, which type of data? Total bill, tape, size. Yes, total bill scale. Tip, yes, continuous, right? Total bill and tab, both are continuous. Yes, and we can write quantitative. Size is discrete, is a countable. So how many customers in the hotel? That is countable. That is discrete data. Total bill and tip is continuous data. Yes. Next, sex and smoker. Sex and smoker. What type of data? Sex and smoker. Yes, nominal. Yes, right. Nominal, sex and smoker. Very good. Next, day and time. Day and time. So next, day and time. What type of data? Yeah, day is nominal, time is quantitative. No, time is qualitative. Here, day is Sunday, Monday, Tuesday, Wednesday. Okay. Time is lunch and dinner. Yes. Okay. These are qualitative data. So now clear how to identify the data type. Okay. First, select what type of data you have, either nominal or ordinal or interval or ratio. Okay. So you can mainly identify the two types of data. One is numerical data. One is categorical data. Numerical means we can express it in numbers. Categorical, we can't express it in numbers. Yes. Next. So what is statistics? We discussed in last 3 sessions. What is stats? What is stats? So what is the use of stats in research? What is stats? What is the use of stats in research? Yeah, inference, decision making, right? Information, right? Yes, the right. Simple converting data into information, that is stats. Okay, converting data into information is stat. Based on the information, management will take the decision. Okay, the simple definition is converting data into information. Based on the information, management will take the decision. Okay, now we have data set, either categorical data, numerical data. Based on the data, based on the objective, we can select the statistical methods. Here we have 2 statistical methods. One is descriptive, one is inferential stats. One is descriptive, second one is inferential stats. Okay, one is descriptive, one is inferential stats. So what is descriptive stats? Descriptive stats. Are you seeing my screen, PPT screen?
Yes, Rameshji, we are able to see.
Yeah. Yes. The main agenda for descriptive stats, describe the data. Okay. The main purpose of descriptive stats, describe the data, like mean, median, mode. Some people are confusing, can I use descriptive stats or inferential stats? If you are secondary data or primary data, you have to use descriptive stats. It is compulsory. If your research project or research articles, you have to use compulsory descriptive stats. So what is the purpose of descriptive stats? You can describe the data. So before applying inferential stat, we have to understand the data. For data understanding, we can apply the descriptive stats. Either you can apply t-test or z-test or correlation, regression, Anova, some advanced factor analysis, structural equation model. So anything, first describe the data. So how to describe the data? Using descriptive stats, we have 3 methods in descriptive stats. Okay, one is organizing the data. Second is displaying the data. Third is summarize the data. Okay. In the second day session, we already completed summarize the data using measure of central tendency, measure of dispersion, like mean, median, mode, okay, standard deviation rate. That is summarize the data using measure of central tendency, measure of dispersion. For organizing the data, we can use frequency distribution tables. In Excel, we call pivot table, or in SPSS, we call cross tabulation. Okay, we organizing the data using frequency table, summarize the data using mean, median, mode, displaying the data graphs. Okay, in today's session, we discuss about graphs, different types of graphs. Graphs also select the based on the what type of data. So clear descriptive stats. Yeah, what is the difference between mean and median? So which type of data you have? If you have quantitative data, you can select mean and median. Anything okay. What is the difference between mean and median? So which is suitable for your data set? What is the difference between mean and median? Based on normality, okay. Median is the middle data. That is right. So what is the purpose of mean and median? So which one is suitable for your data set? Both are central tendency. So both are suitable data set. So for example, I have five data points like 1, 6, 4, 9, 5. 1, 4, 6, 9, 5. So what is the mean and what is the median here? What is the mean and what is the median here? 1, 6, 4, 9, 5. What is the mean and what is the median? Yes, mean is 5. Median. So median 4, 4, some people 5. What is the median? So median is 4. So everyone texted median is 4, 4. Only some texted 5. Which one is right? 4 or 5? Median. Yeah, 4 texted 4. 4. 5 is the right answer, median. Before finding the median, first arrange the data in array. That means ascending or descending order. Okay, before finding the median, first arrange the data, ascending or descending order, select the middle, that is the median. So average is the 5. So which is suitable here, mean or median? So which is suitable here? Yeah, 5 is the mean, median also 5. So people tested median, people tested mean. Okay, both are right. Mean and median, you can select anything. Suppose I am adding one more point instead of 16495. I'll add one more data point 100. So what is the mean? What is the median here? 14695. I'm adding 100. What is the mean? What is the median? One, 4, 6, 9, 5, 100. So what is the mean? What is the median? Yeah, mean is 20.83, right? It's approximately 21. Yes, what is the median? Yes, median is 5.5. Yes. 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 In this case, we can select the median is a right model. So why median is right? The simple agenda is here. You can select this test based on your data type. Okay. Here, let's see here 1, 4, 5, 6, 9. Okay. The mean is 5, median is 5. You can select anything. Okay. In 1, 4, 6, 9, 5, 10, 100, the mean is 21 approximately, median is 5.5. If you're adding one value, the mean is 4 times. If you're adding one value, median is approximately same to the previous data set. So you can select the mean if no outliers. If you have outlier in your data set, you can select the median. Okay. So median is suitable if you have data outliers, because mean is affected by outliers. If you have outliers in your data, you can select the mean. If no outliers, you can select the median. So now clear when to select the mean and median? So mean is applicable if no outliers. If you have outliers, median is suitable. It's clear between difference mean and median? Yes, clear. Yes, this is the descriptive stats. Okay. So you have primary data, you can apply descriptive stats for demographic data. If you have secondary data, you can apply. Yes, again repeat that. Yes. Here 1, 4, 6, 9, 10. Sorry, in the initial we have 1, 6, 4, 9, 5. Okay. The mean is 5. Median is 5. If I'm adding extreme value, only one value, the mean is 20.8. Median is 5 point something. If If you're adding 100 is outlier. In the next coming session, I'll explain how to identify the outlier using box plot. Okay, I will explain the outliers using box plot. If you're adding 100, the mean is 20.8, approximately 4 times. Here, median is not much change, approximately same. Previous we got 5, here 5.5. There is not much difference between mean and previous median, current median. So median is not affected by outliers. If you have outliers, you can select the median. If you have no outliers, you can select the mean. So clear? Difference between mean and median? Anyone doubts about mean and median? Yes. Okay. So this is very, very important. So many students observed confusing selecting mean and median, especially confusing t-test, Anova, correlation, regression. Don't worry, I'll give you within 5 minutes how to select the test. Only 2 things you can decide based on your data type, your objective. Okay. So many students depends on others. Okay. No one decide your statistical method, only your objective, your data will be decide your statistical methods. Descriptive is clear. Next, what is inferential stats? Anyone? What is inferential stats? So descriptive only describing the data. So what is inferential statistics? What is inferential statistics? Let's set mobile data to Wi-Fi. Is it visible on my screen? No. Based on the population, we can't decide descriptive or inferential. Okay. Based on your objective, we can decide either descriptive or inferential. We want only describe the data. Okay. We want only describe the data, we can apply descriptive stats. We want some conclusions, you can select the inferential stats. Okay. So your statistical method based on your objectives, not based on the population and sample. So clear? Suppose here what is inferential? Simple conclusions. Conclusion based on the sample. That's about population. The inferential agenda is conclusions based on the sample about the population. So what are the different inferential methods? T-test, Z-test, both are same. In your doing manual, there is much difference. So using softwares like Excel, SPSS, Python, or using any software, there is no much difference between t-test and z-test. If you reject the null hypothesis using t-test, the same result will be obtained by z-test. If you fail to reject the null hypothesis using t-test, the same results by z-test. Okay, results are same either using t-test and z-test. So many software available on t-test. We can discuss only t-test. Next, Anova. Next, chi-square, correlation. Please write down. So many students are confused. So whether I select t-test or Anova, chi-square, correlation. Within 5 minutes, I'll clarify when to select t-test, when to select the regression, when to select the correlation. So what are the main 2 things based on our statistical methods? First is type of data. Second is your object. All statistical method depends on only 2 things. One is data type, one is your object. Okay. Is it clear my voice? texted. Yeah, 1 minute. We'll adjust this.
Uh, Dr. Ramesh, you're not audible. Dr. Ramesh, you're not audible.
Ma'am, I think sir lost his connectivity, ma'am.
Yeah, please, Basvi, take care.
Yeah, ma'am. Yeah, ma'am.
Very quickly, you have to be ready for it.
Yeah, ma'am.
Is it clear now?
Ma'am, sir is joining, ma'am.
Okay, Basvi.
Is it clear?
Yes, sir. Yes, sir. You're audible now.
Yeah. Is it visible on my screen? Yeah, same screen. Okay. Yeah, next our agenda is select the statistical methods. So how to select the method based on our data type? We already discussed data only 2 types. One is quantitative, one is qualitative. Quantitative, we can simply write CV, that is categorical variable. We can't express number here. NV, numerical variable, we can express the numbers. Okay. Yeah, give me one example for categorical variable. So give me one example for categorical variable and numerical variable. Yes, gender. Yes, categorical. Yeah, give me one numerical variable. Height. Okay. Weight. Okay. Salary. Age. Anything. Okay. And select the one categorical variable is gender. One categorical variable is salary. You select any data, either primary or secondary. We have only 2 types of variables. One is categorical variable, numerical variable. You can select the categorical, numerical, or categorical, or numerical. We have only 3 types of combination. Suppose I'm selecting one categorical variable gender, one categorical variable one numerical variable salary. So which test is suitable here? I'm selecting one categorical variable gender, one numerical variable salary. So which test is suitable here? I selected only 2 variables. One is gender, one is salary. So out of 5 tests, which is suitable here? T-test or Anova or chi-square or correlation or regression? Which test is suitable? For gender, for salary. Yeah, T-test, some people texted correlation. Yeah, some people Anova, some people T-test, correlation. Okay, I will explain. Okay. Suppose you have selected one categorical, one numerical. Okay. Keep in mind, if you have selected one categorical and numerical, you can select either T-test or Anova. Just write down. If you have one categorical data, one numerical data, you can select the T-test and Anova. Your objective is comparison between 2 groups or 3 or more groups. Okay. The objective is compare. Data type is one is categorical, one numerical. So when to select the T-test? if you have only two groups. So in gender, we have only two levels or two groups or two samples. We can, whatever we call, some people call groups, some people call sample, some people call levels. In gender, we have only two levels, male and female. In that case, we can use t-test, that is called independent t-test or paired t-test. So clear t-test, if you have one categorical, one numerical variable, you can select the t-test, you have only two levels. Okay, yes, clear. Don't confusing. The simple, your objective is compare, you have one categorical data, one numerical data, then select the t-test. Again, combination, categorical variable and numerical variable. Okay, categorical variable and numerical variable. But here we have more than two levels. Okay, more than two samples, then we can use Anova. Okay, if you have only two levels or two samples, we can t-test. If you have more than two samples, we can use Anova. So clear difference between t-test and Anova? Yeah, if you have third gender, someone texted, for example, if you have gender, if you have primary data, you collected only male and female. In that case, you can apply t-test. In recent, Government of India introduced one more gender, that is transgender. In that case, if you have three levels like male, female, and transgender, you have three levels. In that case, use Anova. Okay. If you have only two levels, you can use t-test. More than two levels, you can use Anova. Okay. Suppose you want to find the salary between gender and gender. For example, my objective is to find the difference between male and female. To find the difference between male and female, okay, with respect to salary. Okay, salary is numerical variable, gender is categorical variable, only two levels, let us assume, male and female. So for comparing between male and female, you can select the t-test. Now my next objective is to compare between management levels. You have three levels of management. Let us assume low level, medium level, high level management. Here more than two groups. We have three groups. You can select the Anova. Okay. If you have more than two levels in your categorical variable and one numerical variable is salary, we can use Anova. So now clear difference between t-test and Anova. Any doubts? Is it clear the difference between t-test and Anova? Very good. It's clear. The simple funda is what type of data, what is your objective. Okay. Here only two types of variables. One is categorical, one is numerical. We can select the T or Anova. In categorical two levels, select the t-test. The t-test is only independent, not dependent t-test. We can discuss what is independent, what is dependent. Okay, we can select the only independent t-test. If you have two levels, we can select the Anova. In Anova, we can use two-way Anova. If you have two factors, three factors, three-way Anova. If more than three, you can use Anova, multivariate Anova. That is some advanced topics. Yes. Yeah. Next combination. What is the next combination? We done categorical numerical variable combination. What is the next combination? We have only two types of variables. One is categorical, one is numerical. What is the next combination? SCV-CV, okay, or NV-NV. If you have only CV-CV, we can use chi-square test, no other options. If both are categorical, we can use chi-square test. Some people are applied chi-square test on numerical data. There is a blunder mistake. Okay, if any software give the results, okay, you shall give chi-square test for numerical data, it will give the output. So chi-square test always for categorical variable. Okay, both are categorical, like gender and smoking behavior. Gender and smoking behavior. Or gender and voting preference. Okay, like gender, like male and female voting preference for NDA or UPA government. So they recently conducted one survey in US election. gender and voting preference to Republican Democratic while contesting Trump and Hillary Clinton. There is a difference between Republican and Democratic parties with respect to gender. If you have to select the chi-square only for categorical. If you have 2 levels or 3 levels, there is no issues. The only agenda is if you have categorical variables. The example is gender and smoker. Yes or no? Here, male or female or transgender. Any levels, there is no issues. Only categorical. The objective is find the association. Okay, the agenda is association. The objective is association. Clear chi-square test? Any doubts in chi-square test? Both are categorical variable. More than 2 also you can select. There is no issues. Yeah, any doubts? Nazir, you raised your hand. Simple. If you have 2 or more categorical variables, select the chi-square test. The objective is find the association test. Yeah, if find the association between gender and voting preference to some political parties. Here, gender is categorical variable, male and female. Voting preference is categorical, NDA and UPA. Is there any association between gender and voting preference to some political parties? Okay, in that case, you can apply chi-square test. Yes. Not for people. Voting preference to some political parties, either NDA or UPA. We are selecting only categorical data. One is UPA, one is NDA. That is one category. Yes. And we can find some association between voting preference, NDA, UPA, and region, south, north, east, west. I found some research on this one. I found some relationship association between voting preference and political parties. Most of the north prefer to UPA. Most of the south prefer to NDA. Okay, there is association. So clear chi-square. Can I move to next method? Yes. Yeah. What is the next combination? Yes, only numerical. So if you have both are numerical, select correlation or regression. Numerical variable, numerical. Give one example for numerical. So we done categorical numerical combination, we done CV combination, remaining only NV. Give one examples for NV variables. Okay. So like gender is one variable, income, yes, right. Age and salary, yes, right. Okay, that is sales and profit, yes. Yeah, anything. For example, your study time and your marks. Okay, study time and marks, or age and your salary, your level of experience and your income. Okay, sales and profit. Okay, demand and price, height and weight, height and distance of your jumping. Okay, so this is all numerical. We can use correlation and regression. First, I apply the correlation. Okay, then apply regression. What is the difference between correlation and regression? What is the difference between correlation and regression? Why do you apply both? What is the difference between correlation and regression? What is the difference? We can discuss in detail in scatter plot. Yes, association. Yeah, association. Instead of association, you are always used for correlation relationship. The best word is in statistical method, use relationship. The best association suitable for chi-square test. Yes, correlation does not focus on causal. Yeah. If discussing depth, regression also not causal. Okay, that is our advanced. We can discuss in the machine learning topic. Yeah. The main aim of correlation just find the relationship between two variables. For example, let us assume R equal to 0.7 for study time and marks. So what is your interpretation here? So the interpretation is very, very important for research scholars. So the SPSS or Excel, anything will give output, either Python or you have to interpret the based on the results. So what is your interpretation? R equal to 0.7. 70% is explained. No, not. That is explanation based on the R square. Yeah, just is R. Yes, R is 0.7. That means there is a strong positive relationship between study time and marks. If, for example, spending time on social network, we are in the third place in spending time on social network. India in third place. We are spending time on social network and marks are equal to minus 0.74. That means there is a strong negative relationship. Okay. So here simple our interpretation is there is a strong positive relation between study time and marks, that is R is 0.7. That means if study time increasing, marks also increasing. If spending time on social network increasing, marks will be decreasing. Okay, that is our interpretation. Simply write R equal to 0.7. There is a strong positive relationship. So from the conclusion, if study time increasing, marks also increasing. If spending time on social network increasing, marks are decreasing. So clear correlation? If one is increasing, other one is increasing, positive. If one is increasing, one is decreasing, negative. Any doubt is correlation? One is increasing, other one is increasing, if positive. If one is increasing, other one is decreasing, if negative. So what is regression? From the correlation, we simply say that if one is increasing, one is increasing, or one is increasing, one is decreasing. But how much increasing, how much decreasing? That one from the regression. That is nothing but beta or b, y equal a plus bx. And regression is a predictive technique. If you know the x value, we can predict the y value. In the 6th or 7th session, we can discuss in detail about regression. From the correlation, just find the relationship. One is increasing, other one is increasing. But how much increasing? If you study extra 1 hour, 2 hour, how many marks are increasing? That is interpreted by beta, regression coefficient. Yeah. So now clear all statistical methods. Yeah. Again, someone asking difference between correlation and regression. Yeah. I'll give example for correlation and regression. The same example, study time and marks equal 0.8. That means positive correlation. If study time increasing, marks also increasing from the correlation. But if someone said if study time increasing, marks are increasing. How many marks increasing? If you study 2 hours extra, if you study 3 hours extra. So that will be depends on regression. For example, y equal to a plus bx. Your y is your marks dependent variable. A is 10, b is, let us assume, 0.6 into your study time. So from the correlation, study time increasing, marks also increasing. How many marks increasing? 1 marks will be if you study extra 1 hour per week or per day, your marks will be increasing. 0.6 marks will be increasing. That is from the regression. Okay, regression is if you 1 unit change in x, there will be b unit change in y. Just write down from the b. If 1 unit change in x, 1 unit change in x, then b units change in y. If you study extra 1 hour, then marks will be changed 0.6. It depends on positive or negative. If the same equation y equal to a minus bx, that means if 1 unit increasing your spending time on social network, then minus 0.6 marks will be decreasing. So now clear correlation and regression? Any doubt? Correlation and regression? So everyone clear? All statistical methods? So now clear when to apply t-test, Anova, chi-square, correlation, regression. Yes, thank you. And one more test we forgot, paired t-test. Some people call dependent t-test. Dependent, some people are paired t-test, but the simple logic is don't forget before after test. This is simple rename you can write before after t-test. That is paired t-test. Before after means Suppose you want to find the same sample in 2 different time periods. For example, after this slide, I will conduct the exam basic charts. After the end of the session, I again will conduct the exam. Is there any difference before training, after training, or after session? In that case, you can apply paired t-test. The sample size is same and sample also same. That is before and after training. What is the performance of employees before and after training? Okay, what is your blood pressure level after joining the meditation course? Okay, what is your weight before and after joining the gym? If you want to find the before and after any particular time period, after any method, you can apply paired t-test. So now clear paired t-test? No, we have to use same sample group. Okay, you have to use same sample group. Okay, if you have an organization, out of 100 employees, I select 30 students or 30 employees. I'll conduct the training method. Before training, what is the performance? Again, I conduct the performance test for that 30 sample only. Sample should be same and sample size should be same before and after. Yes, pre and post experiment. Yes, we can use paired t-test. Yes, we can use same respondent before and after. So now clear paired t-test? Yes. Yes. Don't bother about homogeneous, heterogeneous. Okay. Yeah, it will. Nowadays, we can use software. If you are using SPSS, one advantage of SPSS, it will give the separate result if your data homogeneous, data not homogeneous. Okay. Don't bother about homogeneous, heterogeneous. Yes. Yeah. The output will be same. Yes. I will ask some basic question. What is standard deviation? So in measure of dispersion, we are using standard deviation, variance, range. Okay, this is very, very important, mean and standard deviation. So what is standard deviation? Yes, deviation from the mean. Okay, deviation from the mean. Okay, some basic question. Okay, if you have 10 students, everyone got 10 marks. What is standard deviation? If you have 5 students, everyone got 10 marks. What is standard deviation? If everyone got 10 marks out of 10, what is standard deviation? Yes, standard deviation 0. Because there is everyone got same marks, the mean is 10. Then standard deviation also 0 because there is no difference between individual value and mean. So the standard deviation 0. The simple logic is standard deviation, how much deviation from the mean? That is standard deviation. And why are you using standard deviation, not variance? Standard deviation came from the variance only. First calculate the variance. After square root, we can find the standard deviation. So why we are using standard deviation instead of variance? Anyone answered? Why we are using standard deviation instead of variance? Before standard deviation, can calculate the variance. Why are you using standard deviation instead of variance? Anyone text here? It is a relative measure. So both will give the same result. It is variance also positive value square. Both are give positive. If the variance is 16, standard deviation is 4. So clear? Square root of variance is standard deviation. If your variance is 16, standard deviation is 4. Why are you using standard deviation instead of variance? So variance also find the deviation. Both will give the same. Why are you using standard deviation? It also gives the measurement of measurement. Yeah, approach to the answer is right. The simple logic is, in calculating variance, x minus x bar whole square in the formula. Okay, x minus x bar whole square in the formula. So that means if you have 16 rupee, your units are rupee, variance will be rupee square. The answer is variance equal to 16 rupee square. Is that meaning rupee square? There is no meaning. Okay, then we can convert into square root. Yes, that is right answer, unit of measurement. If there is no meaning for rupee square or dollar square, in that case, we can use standard deviation is the right one. So now clear, descriptive stats, inferential stats. So now I hope you are clear about which statistical methods, what is descriptive, what is inferential. Anyone doubt in descriptive or inferential stats? So there is no difference standard deviation variance. If variance, we get the values in square. If you have rupee, we get the rupee square. So there is no meaning for rupee square, 16 rupees square. We can't express it in 16 rupees square. We can express 16 rupees. So that's why you can use standard deviation. Any other doubts in descriptive and inferential stats? No doubts. Okay. This is the overview of stats. But something is missing in stats. So we discussed descriptive and inferential. There is a relationship between descriptive and inferential. Okay. There is a relationship between descriptive stats and inferential stats. But how to connect that relationship? Using probability and probability distribution. Okay, this is overview of stats. Okay, if there is a relationship between descriptive and inferential stats, we can connect the relationship between both using probability and probability distributions. If you want to know the basic stats, first read descriptive stats. Before moving into inferential, first read probability. In probability distribution, binomial, Poisson, normal. We are mainly focused on normal distribution. Next, inferential stats. Okay, this is the about statistics. So clear everything? Any doubts? So clear which statistical method suitable for what type of data? Yes. Yes, coming to our data set. So if you want to take screenshot, it will give you overview of statistical methods. Everyone open tips data set? Yes. Here, if you're selecting total bill sex, here sex is two categorical variable. Total bill is numerical. Which test is suitable? Sex and total bill. Is it visible on my screen? Excel screen? Yes, T test, right answer. So many are T test. So now clear. One is categorical, one is numerical. Yeah, independent sample T test, right. If you select the total bill and tip, if I'm selecting total bill and tip, yes, both are numerical correlation. If you have categorical, sometimes you can apply correlation that is called Spearman correlation. Yes. If you have ordinal data, yes, now clear. Tip and day. Tip and day. In day, we have Sunday, Thursday, Friday, Saturday, 4 days, 4 level of categories. Tip and day. Tip and day. Anova, yes, clear. Okay. Anova is the right answer. Chi-square, if you have sex and smoker. If you have sex and smoker. Next, sex and smoker. Sex is male and female, smoker, yes or no. Which test? Yes, so many texted chi-square. Yes. Okay, I hope you got some idea when to select the test. Yeah. Very good. Everyone got some clear idea. Yeah. So next we can discuss basic charts, histogram, box plot, scatter plot, bar chart, pie chart, line chart. Please download the data from that link I sent already in text. Okay, we download 3 data sets. First, we can discuss about graphs. First, download the graphs data. Everyone download graphs data set. So why Anova for tip and day? A tip is numerical data. Day is categorical. If you have more than 2 categories, we can use Anova. So your day is Sunday, Thursday, Friday, Saturday. We have 4 categories. Then we can use Anova. Yes, please download the graph data set. Yeah. Yeah. Next, download the graph data set. Before explaining charts, please attend this quiz, basic quiz. I know what's your level of knowledge in stats. Please just, it will take only 2 minutes times. Please just attempt the quiz, basic stats quiz. Everyone received the link in chat box before moving to visualization basics. Received the link in chat box. Received the link. Chat box. Please attempt the quiz. You know the level of knowledge of basic charts. The basic questions here. You have one response. Please try. It's the right or wrong, no issues. Just attempt the quiz. Okay. Here one statistical question. Just attempt the quiz. Whether right or wrong, no issues. Okay. This is a paired t-test. Okay. So this is a real example of paired t-test. So what is the score before? What is the score after this session? Okay. The compare between before session, after session. This is the best example for paired t-test. Okay, 11 responses. Please attempt the quiz. Yeah. So please submit the quiz. Yeah. Shall I move to slides? We can discuss the different types of charts. Yeah. Yeah. So some people are asking me, sir, what is the use of stats? Okay, this is the reasons. If you're done PhD, let's check your reasons in your thesis. If you're doing PhD, select at least one reason. Okay, at least one objective or when point should be matched with your objective or your research. If you're not matched, then you no need to apply any statistical methods. Okay, whether finding the relationship or prediction, describe what is happening. In today's session, we discuss what is describe, what is happening, present the information using graphs. Okay, if you do not find any reason for your research, then you no need to apply statistical methods. Okay. Yeah. So how to select the statistical methods? What are the 2 points? What are the 2 things for selecting statistical methods? One is data. Second one is objective. Okay. One is data. Second one is objective for selecting statistical methods. Here also same. For selecting graphs, you have data, your objective. Data same, categorical, numerical. Okay. So before applying data visualization, you have two key questions. What type of data you have? Only two types, either categorical, that is qualitative, either qualitative or quantitative. Next, what is your objective? Okay. Or you find the relationship, you want compare, you want composition, you want find the distribution, you want trending. Okay. So this is your objectives for visualization. Okay, this is the basics. So here, type of data, what's your objective? Relationship, compare, composition, distribution, trending. Okay, for relationship, you can use scatter. Okay, for relationship between two numerical variable, we can use scatter plot. For comparing between groups with numerical variable, so we can use bar diagram. Comparing between groups with the numerical variable, use bar graph. For composition, divide the data into parts, we can use pie chart. For distribution, we can use histogram and box plot. For trending, we can use line chart. Okay, in today's class, we discussed bar graph for finding the comparison between groups with numerical variable. For histogram, for numerical data, find the distribution. Scatter plot, also numerical variable. Box plot for numerical variable. Line chart for trending. Pie charts divide the data into parts. Okay. First, we discuss the numerical variable. Okay, for numerical variable, we can use histogram, box plot, scatter plot. What is histogram? Anyone? What is the use of histogram? What is the main use of histogram? So this is the basic Excel. We can create charts in easy. Select the data, go to insert, select the chart. If you're using 2010 onwards, it's the recommended charts. You can select the recommended charts. We'll show hands-on. Okay, don't worry. And this is the different methods for modifying your charts. Okay. So what is the use of main histogram? Yes, continuous data, frequency, right? Show the frequency polygon. Yes, right. The main aim is to find the distribution. What type of distribution? Either symmetrical or positive skewed or negative skewed. And one more important point is how many observation in each class. Okay, how many observation in each class. Okay, you collect the data from the students, the marks. How many students marks between 95 to 100? How many student marks are 90 to 100? In that case, we can use histogram. So what is normal distribution? For drawing normal distribution, the basic is histogram. Okay, if you want to draw the normal distribution curve, it's based on the histogram. For example, I have the data. Let us assume our data is the histogram only for numerical data. Okay, here x-axis you can say the scale, y-axis frequencies. Okay, frequencies, that is number of observation or percentages or probability, anything. Either your frequency or probability or percentages. X-axis scale. For example, here 70 to 75 marks. How many students? Let us assume 3 students. 75 to 80. 4 students. 80 to 85. 9. 85 to 90. Right, upper limit. 7 students. 90 to 95. Again 4. 95 above. 95 to 100. 3 students. Okay. Out of 30, this is the marks. So this is the frequency on x-axis, class, frequency on y-axis, class on x-axis. So this is 7, right, scale 3, 6, 9, 12, 15. Okay, sorry, 0, 2, 4, 6, 8, 10. So you can write 0 to, you can write here 70 to 75. Right, just upper limit here 80. Here 85, here 90, 95, 100. So 3, first 3, next 4, next 9 frequency, next 7 frequency, next 4, next 3. Okay, this is the simple histogram. Okay, so this is called histogram. You can divide the data into class. On x-axis, in y-axis, it's a frequency. Okay? The class width is same. Sometimes class width can call bins also. In Excel, we can call bins. Okay, this is the histogram. Okay, yeah, divide the data into bins. So we can apply only for numerical data. The main agenda, what type of frequency, how many observation in each class. In 2 cases, we can use histogram for numerical data. Yeah, this is the example. For example, the same example, total bill. Okay, so this is the histogram. Here, how many customers between total bill $3 to $87? 7 customers. Here, 8 to 13, 50 customers. 13 to 18, 17 customers. Just find the how many customers between the ranges. Okay, that is the second objective. The first object was your distribution. What type of distribution this one? This is what type of distribution this one? Is it positive skewed or negative skewed or symmetrical distribution? Yes, right skewed. Okay, that is the agenda of histogram. You can find the what type of distribution. Yes, that is positive skewed. Okay, how to convert histogram into normal distribution curve or positive skewed? Simple. If you just connect the midpoints of each bar. Connect the midpoints of each bar. Okay, connect the midpoint of each bar to convert into positive skewed or negative skewed or symmetrical distribution. Okay, this is the agenda for normal distribution curve. So normal distribution curve based on your histogram. Okay. Yes. So if you have small data set, you can call polygon. If you have only small data, if less than 30 or 40, we can call polygon. If you increase the sample size, it will convert into symmetrical distribution or positive skewed or negative skewed. So clear histogram. So what are the different types of histograms? So what is the differences? What is your observations from positive skewed, negative skewed? For example, in a class, 60 students, okay, X bar is 70 average score. If your data is symmetrical distribution, then it's a symmetrical distribution. That means 50% of the students below the average score, 50% of the students above the average score. That is the symmetrical distribution. In positive skewed, skewed to the right, negative skewed, skewed to the right, left. In positive skewed, average is again here 70. Most of the students less than average score. In negative skewed, most of the students above the average score. If all are got same marks, that is a uniform distribution. Okay, this is the difference between positive skewed, negative skewed, symmetrical distribution. So this is the relationship between positive skewed, symmetrical skewed, negative skewed. Here, mean, median, mode are equal. Here, in positive skewed, mean is greater than median, median is greater than mode. In negative skewed, mode is greater than median. In both positive, negative skewed, median is always in the middle. So this is the relation between mean, median, mode. If you are symmetrical, all are equal. If you are positive skewed, mean is greater than median and mode. If negative skewed, mode is greater than mean, median, mode. So clear? Any doubts in histogram? This is a basic chart. Any doubts in histogram? Yes. So let's draw histogram in Excel. Just open graphs file. Everyone open Excel graphs file. Yes. Is it visible my screen, Excel screen? Yes. So you want apply histogram only for continuous data, that is numerical data. Okay. Select the numerical data variable, that is total bill. Okay. Your sample size is 244. Please open Excel file, select the total bill column. The simple logic is select the entire column. Otherwise, you can select your total bill, Control Shift down arrow. Okay. Control Shift down arrow. Select the total bill column. Go to insert. Okay. Go to insert. Select the histogram. Okay. This is the simple. Select the data. Select the insert. Select the statistical chart, select the histogram. Under statistical, we have two charts. One is histogram, one is box chart. So clear how to draw the histogram? After drawing histogram, just click on plus. We can add the axis title. We can show the data labels. We can change its chart title. Okay, this is called chart elements. Just click on plus. We can add legend also. Okay, this is simple histogram. So most of the observations are between 13 to 28, 23. Okay, most of the observations between 13 to 23. And what is the distribution here? Total bill? Positive or negative or symmetrical? What is the observations? Yes, positive. So this is your interpretation. In your thesis and your article, draw the histogram. It's a positive skewed. Okay. And most of the observations between 13 to 23 range. Okay. Yeah, next. Find the histogram for tip. Find the histogram for tip. And what is your observation? Find the histogram for the tip. Find the histogram for the tip. What is your observations? Find the histogram for tip. Same, select the tip data. Go to insert, select statistical chart, select the histogram. What is your observations for tip data set? Again, positive skewed. Okay. So we can create again the simple shortcut is I'm just copy paste same chart. Okay. Select the second chart, just drag into left side. It automatically change. Okay. No need to again create one more chart. Just copy that chart, just scrolling the right side, automatically change the chart. Here also positive skewed. Okay. This is the histogram. So clear how to create the histograms? Any doubts? Yeah, both are positive skewed. That means most of the customers paid less than average score. Okay. If you want some reality, I'll show the data set. Yeah. What is your average score? That means positive skewed means if symmetrical distribution, that means 50% of the customers below the mean, 50% of the customers above the mean. If positive skewed, most of the customers below the average score. Let's see in the real. We can always apply some charts. Okay. Otherwise, I will open different file. Yeah, graphs file. Yeah, histogram. Yeah, what is our output? Total bill tip per positive skewed. That means most of the observations are below the average score. Let's see. Go to data. Data analysis. If you don't have that package, you can add, go to options, go to descriptive stats, select OK, select the range from total A1 to Control Shift down arrow, We select the labels in the first row, select the summary stats, we select yes, is it visible my screen? Is it visible my screen?
So your screen is visible, but your voice is little low, sir.
Is it audible now?
Yes, sir. Yes, sir. It is audible now.
Yeah. So we observed total bill is positive skewed. Positive skewed means most of the observations are below the average score. What is our mean? What is here? Yes, 19 point. Okay. So that means out of 244, most of the customers are below the average score. Let's go to sort option. Small to largest. Okay. So average score is 19.78. Out of 244, how many are less than 19.7? Yeah, approximately 146. Okay. So 146 less than average score. It's clear. Out of 240, 140, approximately 60% of customers are less than average. That is the positive skew. This is the beauty of this program. Okay. So clear how to interpret the histogram. You first find the what type of distribution, positive skew, and observation in each class. Next is we get simply positive skewed. That means most of the observations are less than average. Yes, clear. Any doubts in histogram? It's working. Yeah. Any doubts? Yeah. 1 minute connected through Wi-Fi connection. Yeah. Is it visible my screen? PPT screen? One minute. Yes. So next diagram graph is box plot. What is the use of box plot? What is the use of box plot? What is the use of box plot? Anyone? Yes, to find the outliers. Yes, only outliers. Everyone takes only outliers. Any other use for box plot? We have mainly three use. The first one, find the outliers. Second, find the 5 summary measures. Okay. Next, again, we can find the distribution also. Yes, we can discuss. Just write down the numbers 28, 29, 30. We can find the outliers manually. So this is very, very useful chart, box plot. Very interesting chart. in one chart, we can identify the outliers, we can identify the phi summary measure, we can identify the distribution also. I will explain everything detailed. This is one of my favorite chart, box plot. Yes, comparing multiple groups also at a time. That is one advantage also. Yes. Please write down these values. What is the median? Please text your answer in chat box. What is the median here? Please text your answer in chat box. What's the median? 34.5. 34. Some people texted 30, some people 32. I think that is the right answer. So intentionally I gave 25 in the last. Okay. So you have to write, this is first. Okay. The data should be in ascending or descending order before finding the median. Okay. Don't forget that one. Data should be in ascending or descending order. Okay. Now this is an order. Now find the median. Okay. Before finding the median, you have to data in ascending, descending order. So here we can remove 4 elements. Here 4 elements. Here 5. Here, yeah, we have 2 middle values, 30 plus 34. Here 4. Here 4. 30 plus 4. 32 is the median. Okay. The middle value is 32. So the basic. Okay. So median is 32. What is Q1? So median is 32. What is Q1? How to find the Q1? What is the formula? What is Q1? What is Q3? So don't remember that formulas Q1 and Q2. For Q3, sorry, not Q1. So for Q1, again apply the median. So median is divide the data into equal parts. One part is below the median. This 28, 29, 29, 30. The lower part 34, 35, 35, 37, 38 is the upper part. In the lower part, again find the median. In the lower part is 25, 28, 29, 29, 30. What is the median? Lower part. Median is the divide the two equal parts. Yes, 29. 29 is the your Q1. Okay. Next, what is Q3? Upper part, median. Upper part is 35, 35, 37, 38, 34, 35, 37. Yes, 35 is again Q3. This is the simple. Q1 is 29, median is 32. Q3 is 35. Some people call median also Q2. Next, what is minimum? What is maximum? What is minimum? What is maximum? Minimum is 25. Is it visible on my screen, PPT? Maximum is 38. Yes. Okay. Is it visible on my screen, PPT screen? Okay. So this is the 5 summary measure. And what is the main advantage of box plot? Find the outliers. How to identify the outliers? Before finding the outliers, first find the IQR. Okay, IQR is nothing but interquartile range. That is the difference between Q3 minus Q1. Okay, that is the difference between Q3 minus Q1. What is Q3 here? 35, Q1, 29. What is the difference? Yes, that is IQR. So how to identify the outliers? So we have lower boundary, upper boundary. For lower IQR, for upper IQR, for lower Q1 minus 1.5 IQR. for upper Q3 plus 1.5 IQR. If any value below this, we can consider the outlier. If any value above this, we can consider the outliers. If any value below Q1 minus 1.5 IQR, we can treat it as an outlier. If any value above Q3 plus 1.5 IQR, we can treat it as an outlier. So clear how to identify the outliers? Any doubts? How to identify the outliers? If any value below the Q1 minus 1.5 IQR, if any value above the Q1 plus 1.5 IQR, we consider as an outlier. First, find the Q1 and Q3. Next, find the IQR. IQR is nothing but difference between Q1 and Q3. That is IQR. So here, what is Q1? In our data set, what is Q1? 29 minus 1.5. What is IQR? 6. Okay. 29 minus 1.6 is 9. So that is 20. So in our data set, no value below the 20. Okay. Then that is called, there is no outliers. If any value Q3, that is 35 plus 1.5 IQR, that is IQR 6. 35 plus 9, 44. Any value above the 44, there is no outliers. Okay, this is the basics of outliers. Next, if you have observed the box and whisker plot, so the whiskers have same extended in the left and right, and box also same Q1 difference between Q2 equal to difference between Q2 and Q3. Then that is a normal distribution. Okay, both whiskers are same, and box also divided into equal parts. Okay, this is a normal distribution. Let's see in this diagram. Same whiskers are same, and box also divided to equal parts. This is a positive symmetrical distribution. Here in box, right sides moved, and here whisker right side extended. Okay, this is positive skewed. Here we observed box or left side moved. Here whisker left side skewed. This is negative skewed distribution. Okay, so clear? Yeah, so we'll do in Excel. Yeah, shall I extend 10 more minutes? Or 11:30. We have only 2 more charts: bar and pie chart and scatter plot.
You wanted to take 10 more minutes, Ramesh?
Yes, sir. Yes, ma'am.
Yeah, you can extend 10 minutes to 15 minutes, no problem. Please, you can continue.
Okay, thank you. Yeah, next box plot. Open box plot sheet. So box plot also applicable for numerical data. Select the numerical data. Same procedure. Go to insert. Go to statistical charts. Select the box plot. Okay. So this is lower value minimum. This is Q1. It's showing data. Yeah. 113 point. This is the median. This is Q3. This is mean. This is maximum. This is our outliers. Okay. We can find here outliers. If you have outliers, we can apply mean for measure of central tendency. Sorry, median is your measure of central tendency. If you have outliers on the data, you can apply median is for measure of central tendency. Yeah. Next, scatter plot. So first, we can do scatter plot, and we can discuss. We already discussed scatter plot in correlation. The main aim of scatter plot: find the relationship between 2 numerical variables. Okay. Let's select the 2 numerical variables: total bill and tip. Go to insert, recommended chart, or select the scatter plot. Okay. Here x-axis, here y-axis. Most of the time, you can select the x-axis independent, and y-axis dependent. In scatter plot, if you're moving upward direction, there is a positive relationship. If moving negative downward direction, there is a negative relationship. This is easy scatter plot. Yeah, let's see. To find the relationship between numerical data, we can use scatter plot. Okay, like study time and marks, advertisement and sales, income and experience, age and income. So these all are numerical variables. We can apply scatter plot. So based on the direction, we can find whether positive or negative or no correlation. Yes. Next, line chart. What is the use of line chart? What is the purpose of line chart? If you have time series data, if you have any financial data, we can use line chart. Yes, to find the trend, we can use line chart. Yes. First, we discuss all charts. We can do next Excel. Yeah, bar graph is a simple graph. So many research scholars are using this graph. So comparing between groups using numerical data. Comparing between groups using numerical data. So this is real data set where we are in third place in using social media. So this is the same data set, Friday, Saturday, Sunday, Thursday, total bill. So most of the total bill on Saturday and Sunday in weekends. So we can just comparing between groups with numerical data. That is the use of bar graph. Okay, same data we can apply pie chart. The only divide the data into groups and we can convert into percentages. We can do same charts in Excel. Next, we can do some application part. Yes, yeah, go to basic charts. Yeah, graphs. Bar graph, we have categorical data and you can select the, for example, your advertising, rent, supply, salaries, utilities, your different numerical variables. Okay, select the categories. Okay, go to insert, select the chart, recommended chart, select the bar chart, click OK. Okay, this is the bar chart, simple bar chart. You can change the colors, you can add titles, you can add x-axis and y-axis. But you have advertising only one data, rent only one data. But in our data, sex repeated so many times, smoker no yes are repeated so many times. If you want to create the bar graph, this type of data for categorical data, first create the frequency table. So how to create the frequency table in Excel? So how to create frequency table in Excel? So how to create frequency table in Excel? Anyone? So I want to create the frequency table, how many smokers, how many non-smoker, how many male, how many female. So how many customers came on Saturday, Sunday, Thursday, Friday. Okay. In that case, you can use some function, count if function, but it will take time. The simple procedure is create pivot table. Select anywhere, go to insert, go to pivot table, click OK. So I want how many smoker and non-smoker, just drag the smoker into rows. Okay, smoker into values. Okay, this is no and yes. Okay, just create the pivot table. Then select the pivot chart. It automatically give the chart. We can change the colors. If you have data, first select the pivot table for bar chart. We can create bar chart. And next, for pie chart, same procedure. Again, go to bar graph. And this time create for day. Go to insert, create pivot table. Click OK. For day, just drag it rows. Again, day values. So select go to pivot chart. Select the pie chart. Click OK. And select the data labels. Yes, here how many customers on Friday, Saturday, Sunday. And pie chart always represented in percentages. So this is a count. Right click, go to value field setting. Show value as, select percentage of grand total. Click OK. Okay, this is in percentages. This is the different types of charts. Yeah, repeat pivot table. So for creating bar chart and pie chart, first create the frequency table. In create frequency table, you can write countif function, but it will take time. So you can create frequency table using pivot table. So select anywhere in your sheet, anywhere in your data sheet, go to insert, go to pivot table, click OK. For example, I want to find the difference between male and female with respect to total bill. Just drag this X into rows, total bill into values. Okay, this is the female total bill. This is the male total bill. Just go to select the pivot chart. That will give the chart. Okay, it automatically give the chart. So this is female. This is the male chart. So most of the customers are male from the total bill. Yeah, this is the start. So in scatter plot, always Y is dependent, X is independent. Yeah, next. Open Titanic dataset. So after this session, you can apply all these charts on Titanic dataset. You can learn some interesting points. Let's see, within 5 minutes, I'll complete the session. So I applied different statistical charts, whatever discussed till now on Titanic dataset. I'll share the dataset. If you want to download, you can using this website. This is good website for datasets. Okay, if you want some datasets in real datasets, just create your account using Cargill account. Go to datasets. Here's so many datasets. Okay, don't bother about datasets. This is best source for datasets. Okay, you can download the datasets. Yeah, next, same. I downloaded the Titanic dataset. This is real dataset. We observed in the movie also. Let's see within 5 minutes. I'll give some understanding the Titanic dataset based on some charts. Yeah, what is your observations here based on the Titanic dataset? Just data understanding. So we observed here. So most of the customers, most of the passengers from the female category, and most of them are not survived. Okay. Next, again apply the bar plot, survived and gender. Here same. So in the female and the male, so red color indicated they not survived. Okay. Most of the male are not survived. In that movie also, the first priority for female category. So this is interesting points from Titanic data sets based on the charts. Yes. And same based on the class, first class, second class, third class. In that movie, the first priority for wealthy people. So from the third class, in that movie, Leonard belongs to third class. Okay, Kate Winslet belongs to female and first class. That's why she survived. Yeah, Leonard not survived. That is interesting point. Yeah. Next. So most of the male from third category only. Okay, that is a chief. Most of the youth are from third category. So in age. So in age we can apply histogram. What is your observations here? So here most of the passengers from 95 to 190. That from 15 to 30. Okay, approximately 40-30% from the 20 to 30 age group. This is siblings. Okay, how many siblings or how many are partners, spouses? So 0 means there is no siblings, no partners. So allowed customer passengers are more. 608 out of 891, they are singles. So this is box plot for male and survived, not survived. Here also outlier. Here also we find outliers. Same, we can find the outliers. And is there any relationship between age and fare? So this is the numerical data. So age and fare, there is no relationship between age and fare because fare is relationship with wealthy people. Some wealthy people have children, the age is less, and the parents are higher age. Okay, there is no relationship between age and fare. The main agenda for displaying the chart, you have to write to get some information from the numbers by applying different statistical charts. Happy visualizing. Yeah, thank you all.
Dear participants, if you have any questions, you can please ask, sir.
Sorry for some disturbance during the session, some power issues. I already shared PPT with your coordinators. Any questions? Someone posted in scatter plot, in x-axis you can always independent, y-axis dependent. So if you're interested about some visualization, if you want to read some more about in visualization, read this textbook, a very interesting textbook. Yeah, storytelling with data. Okay, this is a very interesting book. How interpret the data using charts.
So there's one question in the chat box.
Yeah.
What is the difference between Anova and Ankua?
So Anova, the main use for find the difference between means. Ankova find the difference between variances. Covariances, not variance, covariances. If you want compare between means, we can use Anova. If you want find the compare covariances between groups, we can use Ankova.
There's another question, sir. Likert scale. If you are using Likert scale, which test to be used?
So Likert scale is under ordinal data. Okay, if your ordinal data, we can apply our chi-square test. And based on our objective, for example, we have 16 Likert scale questions. First, prepare the factor analysis. Okay. After factor analysis, you can create some factors. The Likert scale convert into numerical data. So again, based on numerical data, based on our objective, you can select the statistical test.
Sir, there is another question. What statistical method in different group in pre and post experiment?
Yeah, pre and post experiment, the same test, paired t-test. We can call unpaired paired t-test, sometimes called dependent t-test. We sometimes call before and after t-test.
So there's another question. Mankova is also a variant of Anova. What
Yes,
is that used for?
If you have only one, we can use Anova, one factor, two-way Ankova, two-way Manova. If three-way Anova, more than three, we can use Manova or Mankova, multivariate. So more than three, we can use Manova. The output is same.
What are the data tools used in big data applied in business research?
Big data, we can use Spark or Python. For big data, if you're using always, best tool is Python. In Python,
Sir, which ranking data for ranking data? Which test to be used, sir?
So both the ranks. If you want to find the association, you can use chi-square test. If you find the relationship, you can find the you can use Pearson rank correlation. If you are both are numerical, we can use Pearson. If both are ordinal, we can use Pearson rank correlation.
So the next question is, which statistical graph will be suitable as per the data provided?
It's again depends on your data and your object. Within 1 minute, I'll explain. For data numerical, you find the relationship. You can use scatter plot. You find the distribution, you can use histogram and box plot. You find the outliers, numerical data, you can use box plot. If you have categorical data, you can use bar chart or pie chart.
So there's one more question. Which software to be used? One is SPSS 20 or the another one is R software for international trade and government growth measurements.
For stars or for visualization? For which one? They want for statistics or for visualization?
That is not provided.
If stars, you can use SPSS. Okay. For visualization, you can use Tableau. That is an open source package, Tableau public. And my advice for research scholars, if you're using basic charts, go through. You can use Excel only. Don't use SPSS. If you're after creating a chart, we can import the chart in Word file. If you want to edit that file, if you're using SPSS, again go to SPSS, again create the chart, again edit. If you're doing same chart in Excel, you can edit in Word file only.
So there is another question. Can factor analysis be done in Excel?
No, we can't use factor analysis. Before applying factor analysis, first check whether data is suitable for factor analysis or not. For that one, you can apply KMO test and Bartlett's test. So the two tests is not available in Excel. So then go for SPSS.
Dear participants, any other further questions? You can please unmute yourself and ask, or please post it in the chat box. So there's another question. Likert scale needs factor analysis. So first SPSS.
Yes, factor analysis applicable only for Likert scale. Okay, not for nominal scales. Okay, some people are applying factor scale and nominal scale. That is a blunder mistake. Factor analysis applicable only for Likert scale questions. And before applying factor analysis, whether data is suitable or not, first apply KMO test. After apply KMO, our sample should be suitable or not. Then apply Bartlett's test. If KMO more than 0.7, more than 70%, your data is suitable for factor analysis. And Bartlett's test is significant, your sample also suitable for factor analysis. Any questions?
Sir, how many factors can we take for feasible factor analysis?
Here, two methods. We can be decided by you, by researcher. Otherwise, based on the Skewed plot. In SPS, we have Skewed plot. You can decide the number of factors or based on the eigenvalue. If more than one eigenvalue, we can select the number of factors. For example, 5 factors having more than one eigenvalue, you can select the 5 factors. And percentage of variance explained. Minimum 50% of variance should be explained by 5 factors. So based on the Skewed plot, based on the eigenvalue, based on the percentage of variance explained. I hope your doubt is clear.
Okay, sir. Thank you.
If you want read some more research methodology, go through business research method, David Cooper, and marketing research, Naresh Malhotra. Very interesting books. Marketing research by Naresh Malhotra, business research methodology by David Cooper.
Okay, sir. Thanks.
Dear participants, we hope all your queries are clarified. So one last question, the Likert scale question should be an ordinal or just scale?
So Likert scale should be ordinal. It may be 5-point Likert scale or 7-point Likert scale. For a 5-point Likert scale, strongly disagree, disagree, neutral, agree, strongly agree. It should be ordinal.
Ma'am, as all the questions are answered, shall we proceed further, ma'am? Okay, sir. I would like to now present a formal vote of thanks, sir. At the outset, I thank Dr. K. Ramesh Garu for detailing our participants on which statistical technique to be used when the data is categorical and when the data is numerical. Sir, your knowledge on the subject is commendable. Hope our participants have benefited a lot out of your session, sir. Thank you very, very much. I once again take this opportunity to thank all my participants for being so enthusiastic and participative. Thank you, one and all.
Thank you, Renuka Madam, and thank you, Chaitanya Madam, for giving this opportunity. Yeah, sorry for the delay. During the session, some network issues.
Thank you, sir.
Thank you, Dr. Ramesh.
Yeah, thank you, ma'am.
Thank you.
So, any doubts? Can I leave the session?
Ma'am, you have not shared the feedback link yet.
Yes, ma'am. Yes, ma'am. We are sharing it.
Vasavi, please don't share the YouTube link for the participants. If they
Okay,
are
ma'am. Okay.
attending from YouTube, we will not be able to monitor their attendance. Every day we are monitoring the faculty members' attendance, so we get a graph out of it. So anybody attending the YouTube from YouTube, we will not be able to do that. So dear participants, please don't log in from YouTube. You have to join Zoom only.
Sir, can we get your mail ID, please?
Yeah, I already shared in the PPT.
Thanks a lot, sir.
In the initial only I mentioned my mail ID. Yeah, is it here my mail ID? Or Kandel@Geeta.edu. Madam, can I leave this session? Participants,
Yes, sir.
any doubts?
Yes, Ramesh, yeah, you can leave the session.
Yeah, thank you.
You can. Thank you.
Thank you, sir.